So what I have, I talked about last time the primary component analysis. You have a lot of parameters, you have data, it depends from a lot of parameters, and the method that I will not ask you, even in the test, it's too difficult to do it in a test or here, helps you to select the important parameters. So it gives you some parameters and some variance close to the parameters, and then you can see that the first 2, 3, 4 parameters are important. Which is interesting is that I have something that very similar. I will not talk about this, but I mean in detail. But I will upload something if you want to, if you're interested in. This stuff is very slow, absolutely slow. You have a spacecraft, you have multi-field measurements, and the multi-field measurements has a different variance, and you can determine the surfaces and normal vectors of surfaces based on analyzing this variance. And once it will be great, okay, at least we are here, okay, and then here, minimum here. Okay, this is the method, and we will not go through about it. After a while, you organize the variance and lot of things. You do eigenvalue problem, and it's not important. Okay, and the square of the eigenvalues and also the normal vectors forms an ellipsoid. This looks like this primary component analysis, not the same, but very similar. And when I did this, I prepared for the lesson, and when I talk about this, I always felt I have seen it. And actually, that's it. So this is one method that I used in space physics very frequently, and that's it. So you can determine different surfaces in the plasma, in the solar plasma, and there are a lot of things related to this. Perhaps the next victims next year, I will talk about it. Originally I wanted, but finally I didn't. Next year I will not repeat so many things. I just go through because you remember anything. So I save this right now. I will upload to the Teams, and this is just for you because it's interesting. Okay, let's return to this. Okay, and now we should work together. So I actually didn't figure out why is it important and why do you need use linear algebra for this. We have a reaction equation. Two hydrogen molecules and one oxygen molecule forms two water molecules. That's fine. Okay. Then you can write this reaction in this form. If you check the quantity, please let me know if you are familiar anything that I told you right now, because in the Hungarian class someone is attending a special course and she is familiar in this somehow. So I don't know what will be the outcome of this this lecture and this stuff right now. So this is the equation, and we are only see and consider the amounts, the mole numbers of the molecules. We move the right side to the left side. Actually, not really. We move the left side to the right side and changes everything. Doesn't matter, and we will have this this equation in this form. With numbers, we will have this -2, -1, 2. However, we have no clue what is this, what are these amounts, -2, -1. So we write the formulas about them. This hydrogen to oxygen to water. Great. So now we have a very special matrix called vector. And in this one, there is another reaction. One hydrogen and one oxygen molecule, one means 1 mole, forms hydrogen peroxide. That's funny, actually. I'm pretty sure something is necessary for this reaction. Otherwise, well, doesn't matter. So the life of hairdressers would be easier. So you can do the same with this reaction. The hydrogen and oxygen move to the right side, and then what is going on? Then we have this. So it's -1 hydrogen, -1 oxygen, and then we have 1 hydrogen peroxide. Okay, this is fine. These two stuff is fine. Which is not fine, and do not understand why we should put these in one matrix and why we do this. But if you use hydrogen, oxygen, water, and hydrogen peroxide, you can write the two reactions in this form. Then we have no clue what are the rows. We know what are the columns, so we write the water and the hydrogen peroxide in this form. Okay, now this is something. Does it ring a bell or something like this? Of course, you know the reactions, yeah, but this.
But putting it in a matrix, I don't think I have done it.
And you?
No, we haven't done it in a matrix form. We solved like linear systems of equations, kind of similar, but yeah, no, not the matrix. Not this.
You? Do you remember? Can you recall? Okay, but linear system of linear equations, matrices, linear transformations are the same. So it's we will see. So now we have this matrix. Okay, this is the molecular matrix. I don't know why we did it. Perhaps it's fun. We are clever and smart and whatever. So we did it. Doesn't matter. Okay, we have the molecular matrix, and also we check the component. Now we have more formulas: hydrogen, methane, then ethane and ethylene. How do you? Can you tell the name of the last two?
the last one?
Ethene, yes, yes, and then ethan. Is it the right pronunciation? Ethane and ethan, ethan and ethene. Ethene.
Ethene. E and Y.
Okay.
It's kind of hard to.
Okay. I'm familiar with molecular structure, just I'm not familiar with pronunciation. So native speaker is always good at in the class. But you also something, I don't know, semi-native speaker or something like this because you learn English in your schools. it's interesting stuff. Okay, and we have the atoms. It's carbon and hydrogen. Okay, we can write the quantities. So we have this matrix. Still, I don't know why I have this matrix, but at least I have written the components. You can write the molecular weight to another matrix, and you can multiply them, and then you will have an other form of matrices with weight, molecular weight. Great, I'm very happy with this. And you can see here the linearly dependent and independent vectors. That's very nice. It's I don't know. So it's yeah, it's nice. Okay, and somehow it wants to apply this for balance. Well, I know reactions, and I know at least remember something, and there is something which is how not nuclear but chemical reactors you do, I don't know, different components. But I assume this is something like this. You have these components, you have the formulas that you want to produce, and there should be some balance. And which is interesting here, there are the components, and all components, the atom form of carbon, the atomic form of hydrogen, the molecular form of hydrogen, and also the molecules are written in this matrix. And this is also molecular basis. It's radically different than the previous one. And okay, great. I'm happy with this. Now it fixes this. It transforms to reduce row echelon form, but I know this as upper triangular matrix or trapezoid matrix, trapezoid form. The problem is that I know what is at the end, and we will get an identity matrix. So this we will do the Gauss elimination. We have this number and multiply this row twice of this row from this, and twice of this row from this. Okay. Then we have the same like previously. Okay, it does in 2 steps, but doesn't matter, it's 0. We are happy, nice. Then we check this. First, we multiply divide this by 2, and then that's 1, that's half, 0 is 0. Great. So we have this row, we have the result from this, and then just add twice of this row to this row, and 4 times of this row. So if you calculate this, then you got this. You can do the math, and you will have this type of matrix. Then appoint this stuff, and a very interesting thing will happen here. The interesting thing is that is not the trapezoid form or not the Gauss elimination or extension, that this row is multiplied different numbers, and this number, this half, and also this number, these two, are eliminated. Which is weird that we didn't do this. So previously, when we did the Gauss elimination, we didn't need this. But now we do. It looks like we are creating an inverse. You remember how we did it? It looks as it's not Gauss elimination. It's inverse, and it's not row echelon form. It's an ID form. Okay, then we will have this stuff, and now I appoint this number, pivotal, how do you pronounce? Pivotal, pivot, okay. And I multiply 2 minus 1, 3, and add to these rows. So I got this. This is an identity matrix, and I will get this. So because these numbers had a meaning, this hydrogen, methane, ethane, ethene, then actually we got to the coefficients that is necessary for the reactions. Here you are. So for ethane, that's -1, half of hydrogen, and hydrogen atom, and -1 for methane and hydrogen. Also we have the same. The problem is that I not really understand this. So why do you have a half hydrogen? No, wait, here. Okay, not a half. I have a half methane. Okay? No half methane. What is it? Something is wrong. I feel a disturbance in the force. So this is ethane. Okay. So somehow we have the result in the matrix, and this row echelon form identity matrix somehow project these numbers to the components, and we need for the ethane 1 minus 1 carbon, half weight hydrogen atom, minus 1 hydrogen molecules, and I don't understand why I need molecules when I have atom, so I don't understand this. And then I need half methane. We also can do for this for the no I mixed up. So I need a half carbon. I need minus 1 carbon, a half hydrogen atom, a minus 1 hydrogen molecule, and a methane molecule for the ethane synthesis.
I think, isn't the coefficients, it shows the number of moles that you need, not the actual atoms, but just the amount of moles. So like, if you have half moles.
Yes, just for this I would say, if you don't, I mean, this method, don't say this, I will die very stupidly, because you can do this manually without matrix and everything. So I don't understand what is the sense. Do you have large reactions when you have 100 components?
Not that big, no, but we have more complicated ones that make you thinking that it could be useful, balance the equations. But, yeah. With one this simple, though.
So for example, 10 components?
We haven't had one.
Maybe in the most, like.
Maybe we are going to have it in the future. Just say, so that's not one. No, we haven't done one.
2, 3, 4. I think that's the biggest.
Mm-hmm.
Usually they're split up. Not all 10 at once.
Which is interesting thing. Okay, I see the components. Great. But why do I consider independently the hydrogen atom and the hydrogen molecule? That's weird. So I don't understand exactly what is the point of this. I understand what is going here. It's okay. Just I don't understand the point. Perhaps you understand?
Maybe
Because you are the professional, so I'm not from in chemistry.
maybe the hydrogen molecule is to give an example of what it could make. For example, here it gives the hydrogen atom and hydrogen molecule, which is like zero. You just need one of them. You don't need two of them. But I think one of them is useful for just for an example. I don't know.
But I mean, solve it linearly, or is the same as solving it linearly, like adding the equations. It's the same thing. I think this one is more complex since it's easier to solve it linearly.
Yeah, I've never seen where they split the hydrogen and the diatomic.
So it's weird. Okay. Well, this is a kind of linear combination, which is very funny again. Yes, the atom and the molecule are different, but I don't know the meaning of it. Okay, so this is what we had done. This describes how to build up the molecular matrix. We do what we had done, and every row is still, how do you pronounce this? Stoichiometrically, how do you pronounce this?
Stoichiometric.
Can you pronounce this?
Stoichiometric.
You?
Yeah,
Stoichiometric. Okay, so S value. Sorry. We also have very long words, like doesn't matter, and the Germans also have something. Last Sunday there was a conference. I meet someone, and instead of cheers we say egészségünkre. Doesn't matter. So that's the revenge, actually, for these times. Okay, so we have this, and we are happy with this. This is a method. This is what's sent by Gabriel and Roy, and they have a special course, and the special course they use this R for something. The method. Perhaps the method does the same that we had just done. Okay. Okay, there are more interesting stuff. I hope they are these at least still straight line and branches and not aromatic or something like this, because I don't know anything about them. I forgot everything. Okay, here we have what we have. We have different. Is this C8H16? Is this aromatic, or it's a ring, or this is something straight with branches, or what?
Calculate the number of double bonds and tell you.
I don't think it's a ring.
C8.
Yeah, the last one. Is it still?
I think it's the alkane. I don't think it's the
Okay.
Yeah, it's not.
Okay, great. Still, but it has no importance because it seems to be it deals with all the components. Okay, so we have these, and then we write down the molecular matrix, and it is not written here, and I don't see anywhere, but I think the rows, they have this C4H8, C4, okay, wait. Isomers. Oh, great, that's nice. What is C and T isomer? I know what is isomer, but what is C and T?
Maybe cis and trans.
Cis?
Yeah.
The trans, and what are they?
In Hungarian, is the word trying to start with an E. C and E isomers.
But I think, is it represented with Z and E? Or what?
Z?
Yeah.
Z and E.
Yeah.
Not C and
Z is this.
Yeah.
E is savory.
I understand. It's the location of
Yes.
one end of the molecule. It was long time ago, the secondary school. So it's, Okay, then there are two, that's interesting. Yes, and then we have this molecular stuff, and we transform everything in row echelon form. But I think here there is a trouble. The trouble is that there is this second row where that's empty after some transformation. Doesn't matter. We have the components and we are happy. Not exactly understand why, but we are happy. Okay, say different order of components. It also does this. Actually, I think that's an inversion or something like this. It's not row echelon form or whatever. Wait a minute. I must miss something. Ah, the internet connection is. My daughters like these dinosaurs because they can play with it when there is no internet connection. Reduce row echelon form. Okay, one image. Oh, really like it. It should be in other languages. This is the row echelon form, the trapezoid form that I called. Okay, doesn't matter. I think there's a misunderstanding. At least I misunderstood something. So this row echelon form is this reduced row echelon form means an inversion or something like this. So you inversion the elemental transformations. It also evaluates this stuff. Here this is the order of the molecular weight, the components. Well, it's the same, but here I see I need. I don't understand. Oh, it's twice. I don't understand. It's C carbon dioxide. It's for example, this 2.40, the circulation. Here I see CO2. On the other side, I should see 1C and 2 oxygen somehow. But I see 0 oxygen, 0 carbon and minus. I don't understand what's this.
Can you zoom in, please?
Oh yes, thanks. You should tell me earlier that you don't see anything. Here. So I have this.
It simply just states what coefficient of each substance needs to be. I don't really get it.
That's okay. This is also okay. But what is not okay, the result. For example, this one, this 2.14. Here I see,
What's CT versus just carbon? What's CT mean?
the total, yes, total amount, that's fine. This is the, okay, there are two C. One C is the molecule.
Yes.
That is not molecule, it's stupidness. And then the other C is the
Atom.
atom, but not that atom, the component atom. And then that's why they have this T and O. It's fine, just I do not understand what this.
The moles of CO2, the moles of total carbon minus the moles of unbonded, or minus the moles of carbon dioxide.
Yes, it don't make any sense.
This is simply just refining the coefficients and numbers. It doesn't actually make any. I don't know.
Nothing. No explanation. Nothing. It has. I think you might be right. No. It's a mixture containing atomic carbon. Okay, and then no, it's something else.
So it's like the total moles of carbon minus the moles of atomic carbon minus the moles of carbon dioxide will equal the moles of CO2 in the mixture. I think that's what that equation is saying.
Okay, so we have something. Doesn't matter. That's why I talk about this at the last lesson, because everything else was explained that is in the syllabus. Actually, I modified the syllabus on the in the Neptune tonight. Actually, I have modified in the middle of March once, but no one cared. But now I modify and I will remove some stupid part. Stupid part, for example, Gram-Smith orthogonalization, you have learned it. Stupid part is uh, there were two methods for calculating inverse matrix and something else that was more difficult than, that was perfectly useless. I wrote them in the syllabus, but in the topics, but they are strike out, so it's, I will not ask them. Is it okay if I ask you about Fourier transformation by and the noise filtering by words?
Just theory.
Essay, in essay form. Okay, great. But it's for example. Okay, still we have this. Okay, linear code, nice. What's it feeling? Okay, we have chlor, we have carbon, we have hydrogen, chlor, we have molecular matrix with it. It is a very weird form. Here, look, it should be 1, and here it should be 1, but it's not 1. It's very weird. And also, I see this. Okay, so it augmented matrix, and the result of this augmented matrix says the I got it. Not here. No, it's not that one. Not that one. But at least here, because we don't have here nothing, this chlor, the amount of this chlor, is the amount of carbon and hydrogen. But this is something that you know, I think, from somewhere else. Okay. Okay. This seems to be the same. I think they want to describe somehow bonds or something like this. Okay, here what I see is what we know, what balance is between the hydrogen, oxygen, water, and the hydrogen peroxide. Do you see anything else in this? Oh, I don't know. Perhaps it was not a good idea to ask them what to teach you. It's something similar.
What is R?
That's a good question. This is what I try to figure out. Reactions.
Reactions.
Yes, but what reactions? So just add something to the three columns to the, and why three reactions? Why not one or two? No, two should be. No, it's hydrogen, oxygen can form hydrogen peroxide and water, which is the third.
Yeah, I think it's okay if it's three reactions. I think it's hydrogen and oxygen come from water, hydrogen and oxygen come from hydrogen peroxide, and then water plus oxygen come from hydrogen peroxide. So it's three reactions.
Which is the third?
Water and oxygen come from hydrogen peroxide.
Okay, I understand then. Okay, then, okay, great.
It's right above, yeah, water plus oxygen.
Yes, it's
It's the,
okay. So this is oxygen, but in reality, how do you produce hydrogen peroxide?
Usually with sodium and oxygen, it will create sodium peroxide, and then after that we react it with water. Not with pure hydrogen peroxide. If we want to do that, we must have a catalyst or something that will help the reaction because it's a vigorous reaction. So
Okay. So this is hydrogen peroxide from water and oxygen. From hydrogen peroxide, water and oxygen, and then yes, okay. I understand. So there, we creating water, we creating hydrogen peroxide, and from water and oxygen we creating hydrogen peroxide. That's the first one, and these are the reactions. And then we do the transformation. So I think perhaps this determines something about the ratio of these reactions, how they go and how many percent or which part of this reaction is done. Okay, perhaps you understand it. Enthalpy, great, very nice. Okay, the situation is developing. All T numbers, I don't know how to pronounce. Transparent. Wow. And this is a Python code. So, time is up. I hope you became smarter. I don't know. I didn't. And perhaps that's the first thing that is useful for you in this semester. If it is, I don't know. So thank you very much. Have a nice holiday. It's 1st of May, the celebration of the International Proletariat. It is on 6th of September in the United States. I didn't know it, and also someone else who visited me once that they didn't know that that's a national holiday in Hungary. Okay, thank you very much.